Jumping statements. Verilog is not providing a new explicit jumping statements, but the functionality can be achieved by the disable statement. Systemverilog added 3 explicit jumping statement. The break statement will break the execution of current block and jump out to the next statement in the code. Continue statement will skip the following statements in the loop and continue to next iteration of the loop. These are similar to those in C and C++. The return statement is used to stop the execution of a function or task and return to the calling point. It can be used with both function and task. Here is an example of a Verilog disable statement usage to break and continue in loops. It is intended to find the first bit set between a start bit and end bit in a variable. You can see that these begin keywords are named. When the disable my continue point is executed, it will go back to this point, which is equivalent to a continue statement. Similarly, when disable my break point is executed, it will go out of the loop to this point, which is effectively a break statement. If you write the same program in Systemverilog, you can simply use the break and continue keywords here. It is difficult to summarize the synthesis behavior of these jump statement. The best way to map them to the circuit is to unroll the loops in the program, by considering break, continue, and return statement, similar to the example you have seen in the loop synthesis. A simple example of unrolling loop with break and continue is shown here. Here the for loop is calling continue statement if the looping variable I is 2, and calling break when I is 6. The actual statement in the for loop is x equals exclusive or of a of I and b of I. When the loop is unrolled, the continue statement will cause to skip the body when looping variable is 2, and break will cause to exit the loop when it is 6. Thus these 3 statements will not be present. Note that A and B are of width 8, and as these 2 statements are skipped, output of bit 1 operation will be connected to bit 3, instead of bit 2, and bit 5 XOR output will be the final output.